Hello, everyone. Let's dive into it using Airflow to orchestrate DBT. So to give a quick context on, outline of how we will go about things, I'll quickly talk about the context, the problem, why this might be interesting, who I am and all that sort of stuff, things about authoring DAGs or things about authoring your runs. How do you orchestrate it? A little bit about deployments, and a lot of stuff that is usually left out in my mind is the post-deployment stuff, what happens after things are in production. So a little bit of best practices and lessons learned there. For context, I'm Nehil. I am a data engineer at SnapTravel, and I have done a whole slew of things. Originally, I come from engineering background, so I've built services, I've done data infrastructure, data engineering, and now analytics engineering as the organization needs scales. And our stack here is Stitch, Airflow, Snowflake, and DBT. I really love the stack. I mean, Stitch is iffy, debatable, but apart from that, I really like it. SnapTravel is a travel startup. What we are aiming to do is make getting hotels easier over chat and personalized. We are based out of Toronto, and this is the data team. The data team is of 8 people, which comprises of data engineers and data analysts, or analytics engineers. And we have 86 sources and around 300 models, which is all a mixture of views, tables, incremental models, etc., which makes it interesting to manage orchestration of DBT runs. And you would have heard me in multiple office hours discussing like what to do with incremental runs versus not incremental runs, about full refreshes, etc. So purpose. So purpose specifically for me for this talk is to share a tool set, or at least different choices you have in your tool set when it comes to orchestrating DBT runs with Airflow, and share some ideas from the lessons we have learned, and also very, very hungry for feedback in what we could improve in how we have set it up, and different challenges people see with doing Airflow-based DBT runs, because I know a lot of people are already using Airflow for their production DBT runs. So eager to listen to what kind of setup you guys have. Quickly, for what is Airflow? So I'm not sure what the make of the audience is, but before we dive into orchestrating with Airflow, we should know what Airflow is. But before we even get there, I would ask you to stop. If you're at a point where you don't know what Airflow is, then there are other options. As Claire mentioned, I would go with DBT Cloud right away because it's a pay-to-play game, and you can quickly get business value and then figure out the complexity of different things by using Airflow. So I think if you're at the point where Airflow is not part of your ecosystem, or you don't have enough knowledge to how to set it up and what Airflow is, then DBT Cloud is a very good alternative. And we ourselves, even though we had Airflow in our stack, still started with DBT Cloud just because we wanted to prove the value of DBT and getting the value to business faster, and then that bought us time to actually implement it properly in Airflow. What is Airflow? So Airflow is an open source Python, let's say, tool, and it is similar to DBT. It plays in the data realm, but its specialty is to orchestrate workflows. So you can programmatically do workflow management, which means you can define what a workflow is, which is basically a graph of different things that needs to run, and the schedule at which it runs. Do you want to do retries and all that sort of stuff? This slide itself can be a full-blown talk, and there's a lot of material out there on Airflow already. Airflow is very popular now. It's around 20K stars on GitHub. It is part of Apache, so it's very stable and used by most of the enterprises as well. So I think that should be, you should be able to get and learn what Airflow is outside of the talk. Some primitives that will be useful to know what I'm talking about down in the talk. To know our DAGs. So DAG stands for Direct Acyclic Graph. You would have read this term in DBT docs as well, where it's a dependency of different things. In the DBT world, it is DBT models. In Airflow world, it is more generic, so it is a task. A task is any work that needs to be done which might have dependency downstream or upstream, which means like I need to make my coffee. Before I make my coffee, I need to buy ingredients. So this is like a DAG in a way, and you can do that for different types of workflows. Tasks, so different DAGs are made of different tasks, and operators are, it's an Airflow term to say what work is exactly done in a task. And there are different types of operators which wrap what is called as hooks, which is a hook into a third-party thing. It can be an API, it can be a database, it can be anything that you can wrap around a Python class, and then you can say I have hooked into the GitHub API or the database, Postgres database, whatever. And operators do some work with the hooks to create tasks, to generate or to eventually be part of a DAG. So that's at a high level what Airflow is. And yeah. Okay, so let's talk about authoring, which is the first thing you would do is before you could deploy something, you would have to author a DAG, which is comprised of the tasks. So let's look at few kind of ways you can do DBT runs and what those tasks might look like. So one option you have is BashOperator. This came with the first version of Airflow, pretty old and stable thing. It just executes simply a bash command. Like, it's not more complicated than that. All the logs go to std out, and if the command exited successfully, the task will exit successfully. That's basically it. This is what the code looks like. Some caveats from me personally is I feel like Bash is a language which analysts are far, far away from in general, in my experience. So I don't prefer it that much. It also can be hard to sometimes understand and get stuck with quotations in Bash and how it does evaluation of things, etc. But if it's a very simple run, if you're just running DBT run or DBT test, like there isn't much complicated happening in your Bash command, then this is a good option. The second option is written by Andrew from Go Cardless. It is a custom operator, which is DBT operator, which has run and test operators. So we use this at SnapTravel, and this makes it a little bit more pleasant and readable to do the same thing which the bash command was doing, but inside a specific operator which can handle different things for you. So this is what the code would look like if it is like a run and a test DAG. Simply you have some your configuration, and then you create a DAG where you say this is my run operator, and this becomes your run task, and then this is your test operator, which becomes your test task, and then you just say dependency. After my run is finished, run my test run. So that's what it is. Some advantages of DBT operator it's easy to read. This is a very simplified version. If you go to the GitHub page, which is linked at the end in my slides, you will see that they have a lot of different options, which the DBT run command automatically exposes to you in your CLI as well. It is extensible. So what I mean by this is you can do some fancy stuff with the output of DBT in the operator, which can help you get more value out of the operator itself than just a bash operator. You can, for example, parse the output and generate different kind of dependency graph downstream, or you can parse the output and have different kind of messages spit to Slack, whatever else you want. All that can be done in the DBT run operator, which is a Python wrapper around the shell command, which is DBT run or whatever. So again, thanks to Andrew for starting this. It is extensible. So as DBT keeps making the run commands and the test commands better, we can keep adding functionality to this to basically fit our needs. One problem we have right now is it's lacking completeness in the sense that DBT is moving faster than the repo. So it only has run and test operator, but DBT has a lot more commands which might be useful for orchestration job. So what you'll have to do is you'll have to extend it and increase the coverage that we have on the different operators. And for that, you would need an engineer to do it, ideally. But analysts can do it. I found that analysts don't like doing it, at least at SnapTravel, and they're really good at doing analytics engineering, analytics, but when it comes to like contributing to open source with Python code and playing with Airflow, they're a little bit, they don't like it that much. Okay, so now that you have different tasks, and these were the two main options, I think there are to write tasks, then you have to combine them into a DAG, right? And once you have your DAG, you are ready to run it in production or wherever to orchestrate the whole thing on a cadence with different configurations. So let's look at what that looks like. So one option we have, apart from, of course, sorry, just to go back, apart from just writing it like this, which gives you a lot of flexibility, which gives you ways to change things more programmatically. Another way to do it is do it statically with YAML files. And there's a plugin called DagFactory, which does it for you, where you can just define a YAML file, very similar to all the YAMLs you write in DBT. So this should be very familiar to all the people who are working with DBT in general. And that itself is the definition of the DAG. And then Airflow can read it and create a DAG out of it because it's programmatically able to do workflow management. So for example, if you see here, these are some configs. This is the start date. This is the schedule. It should run like every day at 3 a.m. For example, you can add some description, and then you define your tasks simply again statically in a YAML format. And you can see, so it's using this BashOperator. You can swap it to whatever operator you want. So some advantages here is YAML for static configs, and I say it's an advantage because most of the people in DBT already write a lot of schema YAML, so they should be familiar with them. They don't need to know Python, or they don't need to know Airflow primitives because all of that is abstracted for them. And you can take it a step further where you can even like simply make a form and people can write stuff in there and it can generate this in a templated fashion inside your repo. So there are many things you can even put on top of this depending on your organizational needs. And yeah, I find it very pleasant to work with. Another option that exists, and then I recently came across this, but I haven't played personally with it, but I think this is also a potential use case I've seen happen in multiple organizations, is you just have, so because Airflow is extensible, you can have a UI in there for people to, using the UI, to generate a DAG. And so if, this is slightly hard to read because I've obfuscated a lot of detail, but this is a UI inside Airflow. And what they're saying is you can click any node. So for example, they've selected this one and you can just say add task. Then you choose what type of task you want, what is the name of the task, all the things that you're seeing as parameters, as parameters here, you can, this UI will expose it here, and then you can fill those out. And you can imagine like if you're just writing a DBT shell command in there, so you can have the bash option and disregard all these and just add your DBT command. This will be very similar to the experience someone has when they're working with DBT Cloud, except they don't have to imagine the dependency of a task with other things. It's just sequential DBT commands in DBT Cloud. And you can emulate that very, very easily here. Again, some advantages here is it will have one-time setup. So you don't even have to set up anything multiple times. You just set this plugin up in your Airflow, which should be very, very easy. It gets analysts to deploy their runs or orchestrate their runs very quickly because you can directly do it on production UI. You don't have to even go through the whole version control and review process, which in my mind is a double-edged sword because it can be painful or dangerous for people who are managing the repo to not be able to version control and review these things, and people are just making changes in the UI directly. Another things which come from even DagFactory as well is no Python, no Airflow primitive. But on top of that, no local setup. Like you don't have to have any setup locally apart from just your DBT workflow and workspace, which is in a separate repo if you want. And that's it. Like you don't need to have Airflow setup or Python setup locally for Airflow or Docker or all that sort of stuff. So that's an advantage of this as well. So those are two options apart from writing vanilla Python, let's say, to author DAGs. I already discussed tasks. Now, suppose you have a DAG, how would you go about actually doing things in production? So I think there are two good ways to do this. Integration of DBT into Airflow. One way which I prefer more than the other is use it as package. Make your DBT repo a package and then have a very thin DBT project in your Airflow with just packages.yaml, no models, and then a DBT project YAML to define all the configs, and that's it. And then every time a DBT run happens, it actually installs the packages for you. And then you never have to worry about which code is out of date and how do they integrate and all this other stuff. The other way is to do as a mono repo where it's maybe primarily a DBT repo, and then Airflow is just part of the orchestrator there. But then if you already have Airflow doing other stuff, then this becomes hard, where your repo will become really big. I am not really a fan of mono repo. There are arguments for and against it, but that is another easy way to integrate Airflow and DBT together. So once your DBT is integrated with Airflow and you know how to author it, what are the different orchestrations you will do, or what are the different jobs you will run? So I'll discuss these different types. So one will be one time, then there's a way to think about it as source ELPs. The other ones are decoupled from sources. And then there's this, recently I found another discourse conversation about converting DBT manifest JSON into an Airflow DAG. That is an option. I think it adds a lot of complexity where we probably don't need it. I haven't tried it out, but after reading the conversation and thinking about from first principles what they were doing, it does make sense. It will become easier once there is a direct Python hook into DBT instead of the CLI version or Bash version, which I know is being worked on. But I don't really see a need for that, at least right now. You do get a lot of flexibility on actually looking at a model per task in Airflow, but again, I don't know if we really need it. So I would not discuss the convert DBT DAG into an Airflow DAG one-on-one, but the other top three. So one-time things that you would want to do is, you know, install your dependencies, seeds, docs, and I would say the best place to do that is in your CI pipeline and not to do it regularly. This is contrary to some people who are running docs on like a regular cadence, and I wanted to know what is the rationale for that. So probably we can discuss that later today in the Q&A, but our rationale is that if a run failed, the doc should still be available for business team to self-serve data from other parts of the organization instead of completely taking the website down and people being blindsided on using data. So yeah, use CI, which is a great place for one-time things. Seed and dependencies only change when the code in the repo change, and CI will run every time you merge to master. So I think that's a good place to orchestrate things. The second style is sources ELT. So if you look at this DAG conceptually, so a lot of, we had 86 sources, as you can imagine, that things can get complicated in terms of when things land in our Snowflake and all that sort of stuff. So what we did was we started using ELT all the way through, where if you look at this DAG conceptually, you have Great Expectations, which is another library similar to DBT, but just a test part. And it will help you check if your data source is ready to do the run. Once you know that the data is there, so let's take an example. Let's take Google Analytics, or no, that's not a good example, but let's take Facebook ads report. So that is coming from an API. So with the Great Expectations, you can check if the data is ready and it matches your assumptions, which means that we can run ELT on it. And once we know that that test passes, we can run extract and load using Singer, which is the open source version of Stitch. You can use whatever, Fivetran, Singer, Stitch, whatever you want, but it basically extracts and loads it into Snowflake raw, which is where DBT shines. And then we run source freshness on DBT to check all the assumptions and all the way the things were loaded are correct. Run our transform just for our data source, and then run our tests. And there you have it. You have your data refreshed for that specific source and all the dependencies for it. A lot of times, it doesn't make sense to keep refreshing that data, keep running the transform because the source is not changing your data set. So we can just tightly couple our transformation with our sources. This works very well. We don't have to worry about the timing because the timing is decided by our source. And the business teams also don't have any problems with it, that we need data real time or fresher than that because the source is not giving us that data any faster than that. So, so this is one way of doing it. It is, we have found a lot of success with this, at least for cases where data is not coming in real time and there's a batch element to when we extract and load the data. The other ones are where you are decoupled with the sources, where you want to run runs regardless of when the source was updated or your source data was updated. And we broke it into 2 runs, nightly and hourly. Again, depending on the business use case and depending on the complexity and the size of the data. So this is a DagFactory example of how it would look like. So at 3 a.m., our job is triggered, which first checks all the sources. Very important to do, otherwise you're wasting all your compute, running all the rest of the stuff. And then it runs your nightly tags, and then it tests your nightly tags. So both for nightly and hourly, we use tags to achieve what we want. And this is great because you can iterate on it. It's very easy to add tags to models and remove from them, and hence you can move them from nightly to hourly without touching the configuration of how the runs are running. And yeah, so this is fairly easy. And hourly is very similar, except we just exclude everything nightly, and that is hourly. This can get hairy if you want to divide it into multiple runs. But I think it is okay as long as you don't have many different cadences and many different types of runs running in Airflow. And I say that because I don't have a concrete reason, but I've heard that if we have race condition, then we will see some bad side effects of that in our warehouse. So that's why we try to always have only one run running. And you can easily set all those things up in Airflow. You can decide how to only run one DAG or one task at a time. And those are just environment variables which you can set. Another type of job which we have to run every now and then are ad hoc jobs. And we, again, just tag the model as ad hoc. And then if we do that, we exclude it from the other runs. The reasons why we usually need an ad hoc job are mostly for incremental stuff. So suppose you have a really large data set and you want to incrementally work on it, but you're doing it for the first time, or you're adding transformation for the first time, or you want to backfill something because the source updated some data and you have to go back and backfill all of the data that you have already transformed and computed. So these jobs might take a long time, and when they're running, you don't want to run your nightly or hourly jobs on them. And so if you just exclude ad hoc, then you can easily just manage what ad hoc jobs are running. Again, you don't have to change any orchestration. All the tags in the DBT repo will manage everything. But make sure that you exclude the ad hoc. So that's how I think about orchestration. And then it comes to the deployment part. So once we know our DAGs and how we want to run them, next is deployment. So I have put the deployment options in my preference of how I like. I would, even if I start a new project, I would go about it the same way. So Astronomer is Airflow as a service, which basically means you let the experts do what they're good at. And so Astronomer will manage Airflow for you. It will build some tools so that you can easily deploy things, monitor how your system is doing. You can easily scale up, scale down the infrastructure without worrying about it. So Airflow has a lot of different flexibility in how you can scale things. You can just run it on one machine. You can run it on one machine as just the web server and then multiple workers, and you can scale horizontally, but you will have to have a message queue. But with Astronomer, all that is kind of abstracted. It's just a UI, and you can just click a button and you can go from one setup to the other, depending on how you want to scale things. Super easy. It has great CLI. So just to start developing on Airflow, it's as easy as Astronomer start. They have a CLI which they've built to wrap all the complexity in it, becomes really easy to get started, get moving, deploy things. And I'm a huge fan of delivering business value first and then figuring out the complexity later on. So this helps me get there fast. They are active contributors of Apache Airflow, which means that they are almost always up to date in what they're serving as their Airflow as a service is almost always up to date with the latest Apache Airflow features, which is good. And the second and the last thing is good support. So if you're doing self-hosted or like the Google Cloud stuff, the problem is when you get stuck, it might take a long time for you to get things resolved from infrastructure perspective, but they have very good support. So and people have discussed different solutions on their Astronomer Discord, so you can just easily troubleshoot, and we have found a lot of success and help with that as well. The second option is GCP, and that is the Google Cloud Compose. It gives you a lot of things very similar to Astronomer, where it's Airflow as a service, and it abstracts things for you. With config, you can change and scale things. Another added feature which Astronomer doesn't have, but Google gives you, is sync code as a service. Sync your code into GCS, which is you don't have to update your infrastructure or your deployment, and you can just update your code and your Airflow will pick it up because it's syncing in the background the code that you have uploaded in GCS with where it's running in Airflow. For Astronomer, if you do that, what happens is it actually tears the current running Docker instances and create new Docker instances with new code and then publishes them to run. But imagine if there's a job running already, then it might actually wait for the job to finish, or it might kill the job depending on the config. It might kill the job, and only then you can update the code, which is slightly suboptimal because Airflow has a way to look at new code and automatically generate DAGs and run them without actually restarting or doing anything of that sort. It was built in from the beginning. And another great place to use Google Cloud Compose, in my opinion, would be GCP. If you're in GCP all the way and you don't have different things, like you have, if you have BigQuery, or if you want to do something with Dataproc, all those things, they have really good support and hook for that as well. So Google Cloud Compose is great when you're GCP all the way, and Astronomer might not be that useful at that point. The last one is self-hosted. So this is becoming more pleasant as Airflow is maturing after it became part of Apache. When we started at SnapTravel, they didn't have a official Docker image, and it was a lot of pain. Kubernetes was not a thing, so just running that ourselves was not that pleasant. We were spending most of the time just keeping Airflow up, than rather writing DAGs and doing data work, which was not fun. But now they have an official Helm chart, which is super easy if you're in the Kubernetes world to just get Airflow running with simple config. There is going to be the operational upkeep that comes with running a Kubernetes cluster in production and running different services on it. They have Docker as well. And you have to figure out how things work locally versus how things work in production, all that sort of stuff. If you have great infrastructure team or people willing to spend a lot of time on it or resources to spend on it, then this is also a good option. So once you have done your deployment, things are running in production, then it's the small stuff, but it's the last 5%, which no one really cares about that much. But that is very important for how your team performs. So first things first is definitely have monitoring for your DBT runs. This is something I feel DBT Cloud doesn't provide right now. So that would be a good place if you have some specific thing already that you've implemented, like Datadog or something, then that would be one reason why you want to move from DBT Cloud to Airflow, apart from other reasons for customizability and getting deeper access into how you're running things. But yeah, so monitoring is important. I found this site long ago, which we were using, and then we moved to Datadog. But this is a very simple service which helps you start monitoring your DAGs. It's specifically built for writing monitoring stuff for DAGs and not for web services, because just inherently how you look at metrics for a web service versus DAGs is different, or pipelines is different. A pipeline can retry after multiple hours. But a web service only works on a request. If a request didn't work, or if it had too much latency, that's a bad thing. So how monitoring services for websites have been designed slightly don't work with how you want to monitor DAGs. And so I think this is a great place to start. What they do simply is you send them a ping on a URL for an alert you want to create, and then you can have different configs of, I should send a ping every X amount of hours for it to be successful, but you have a grace period of some amount, and then it'll just simply send it to Slack or whatever you want to do with it once there are alerts, or once things are degraded, or when, I don't think it sends alerts when it's successful, but that's what it is. So it's very simple to set up, but adds a lot of value. There are other things like Chronometer, etc., which are slightly more complicated, but they get more feature set. They're more rich. This is just the simple version to start. Some metrics to definitely look at is success rate. That is the number of runs that were successful over total number of runs. Run duration. So this is super important and has hurt us at SnapTravel a bit, where because you were running incremental models, or because you were running models as the thing scaled, the time it took to run all the models or the whole tree, the whole DAG, kept increasing. But imagine you have an hourly DAG, which is taking 1.5 hours tomorrow, and then it's taking 2 hours 1 month later. Eventually you will have just all your models queued up for the day, and it just is not scalable. So you have to keep a check on how long your runs are taking, and you have to keep bringing them inside the SLA of what the run is. And another thing to look at in conjunction with that is queue rate. Are your jobs getting queued a lot? That might mean that your Airflow setup requires scaling, where you can run multiple things quickly, or your warehouse requires scaling up, where it is not able to process things quickly. But you shouldn't have a huge load on your queue, because then it is suboptimal. Another thing is triaging. We learned this from from GitLab's DBT team, and they do this very well. And we basically adopted how they're doing it, where you have one person appointed for, you call them a triager. Their job is to look at all the DBT runs that failed and the tests that are P1 tests that needs to be fixed. Two, if there are any requests coming from business users or outside of the team which need addressing, they address it. It can be a data discovery thing, it can be a data trust thing. They dive deeper into it, but it's one person who's appointed to do this. And from our team's perspective, they also help us keep the tests in check. So whenever tests break, they figure out if we need to do something to prevent that from happening. We usually do round robin. So we have a calendar where we round robin everyone through it, so that it creates a lot of, one, it is fair for everyone, because not everyone likes to be a triager. And so it's unfair if only one person or a few select people of the whole team are tasked with being triagers. And it also is a great place for people to knowledge share and learn about the breadth of what analytics is doing in any team or any company. Regularly track your toil. So this was something we had been doing even before analytics scaled up and we had problems. We just, as a small team who didn't have any DevOps or infrastructure, had this habit of tracking toil, which is basically looking at like, what was the issue, who caught it, how was it fixed, how long did it take to fix it. So there are a few things like we track, but I'm happy to share that. But if you guys want, you can create your own. But for us, it was a simple Excel sheet, like a Google sheet, where the triager or the person who is kind of on call would just set it up and then track. You can find a lot of great patterns and solve them, and you kind of hit multiple birds with one stone type of thing. And it has been instrumental for keeping our team's morale up when things were breaking here and there, which happens a lot in the data team. And a pattern that we found was, at least specifically for DBT, we had the tests were breaking the most then it was the fresh test I was breaking, and then the runs, and which makes sense because runs would be catched by CIs. There wouldn't be bad code being pushed to production, and hence rarely would a run break. Fresh test is common. The data sources do something bad every now and then, because of which fresh tests can break. And then tests is, the business assumptions and the assumptions we have from data are almost always changing, and so they break a lot. And then last but not the least, you should also have good retrospectives around this to keep improving the process. We're still doing it, and we find that as the team scales, the process has to be evolved as well. But it is useful to come together and discuss the learnings. Lastly, so to keep it up, keep fixing the tests, and that can mean three things. You either fix the data, so sometimes you might just have to discard a record, or you might have to change something in the data itself, which can solve the test, which is a legitimate thing to do. Or you can fix the test, of course. Our assumption of the data was wrong, and so you fix the test. And then lastly, if you cannot do either, then you tag in such a way that you skip the test for rest of the runs till a fix is achieved. And this fix might be done by the source team or by someone else outside of the purview of this team. And so you keep the runs successfully finishing while someone is working on fixing that specific test or the data, whatever the case is. Regularly review cost and metrics as things scale, because it's a lot of new infrastructure and setup for teams. Things can get out of hand because of how we want to set up self-serve and give power to everyone to run their DBT runs and orchestrate things. It can get costly to a point where there are diminishing returns, where you're spending more money than you're getting back in terms of the value out of it. That's all I have. Hope that was useful. Thank you. Let's discuss some questions if you guys have any.
Amazing. I love that you said that's all I have. I'm like, there was so much good in there. Thank you so much for sharing that. For anyone that's interested, we'll be sharing, we'll have the video of this up, and we'll also have the slides up as well. So if there was something in there that you want to go back to, we'll make that available. So definitely want to encourage, if anyone has any questions, drop those in the chat, because from now on, we'll just sort of work through these questions chronologically. So Shahid, if you're able to, do you want to introduce yourself and ask your question?
Hi, good to see you again. My name is Shahid. I'm with Squarespace. I had a question. So you touched upon a lot of like amazing stuff. I was just curious, like especially with Snowflake, you have like super flexibility with respect to trying to spin up new instances with respect to like, whether you're testing, validating, etc. I'm just curious, how are you handling like, which the target destination is dynamically, and also how are you parsing the connection details for those?
Right. So that's just basic DBT setup and infrastructure, right? So your DBT project YAML has all those credentials or all those setups. So we always have one schema where all our transform data goes in, and then we have all the different sources, and they are almost always static, they don't change. So where the data goes in doesn't change for production, it changes for CI and for staging. And we have those passed through, we just have a simple script which generates the DBT project YAML programmatically, and then that takes care of it right now. We don't dynamically for different DAGs send the data to different schemas just yet.
Sorry,
got it.
I just want to check there. Nehil, do you mean the profiles.yaml or the project.yaml? For the credentials.
Profiles.yaml, yeah.
Yeah, cool. Just didn't want to send someone down the wrong rabbit hole. So yeah, there's a script that generates your profiles.yml for the right connection details. Cool.
Just one follow-up question. So when you say using just the DBT stuff, so are you passing the the credentials via secrets, or are you just using like the Airflow connection tab and then using connection details from there using DBT variable?
Yeah, so we don't like using UI for storing connections and stuff. It's basically, IAC, infrastructure as code type of practices. So we use secrets. Yeah.
Cool. Thank you.
Cool. Bastian, do you want to ask your question?
Hey, Bastian. Hey again, how are you doing?
Good.
I had a question actually. I was really interested in the type of setup where you were talking about source coupled runs. It's something we've been like thinking about a bit, and somehow it was a bit quick, or maybe I missed a bit how you explained how you do it. So maybe can we get a quick rerun?
Yes, absolutely. Share my screen.
I'm curious mainly on like how you detect like how you select what you run. Sorry.
Yeah. So how you select what you run is basically the data source, right? So assume that I know that all the data that I'm getting from a specific source is going to land here. Okay. That is basically the target for my Singer script in this case, but it can be your other things, right? And then I just trigger everything downstream of that source, which I already know. Okay. And that is almost hard-coded in a way, but that works.
Go. And then like, how do you know when things have changed? I forgot. What was the?
So this one is running on a cadence. So let's say that Google told me that they want to give me a report, an ads report, every 2 days or every like daily at 1 p.m. Because they run in PST time. So then we would trigger that DAG based on when the source is updating, and everything downstream updates based on that.
But you do it because you know when the source is updating, not because you have a little process that detects a change or something like that, right?
So we are running. So as I said in this is a conceptual diagram, but what it's saying is you test if the source is actually ready with the data. Even if, so true story, even if Google says they are ready at 1 p.m., they're not. And we have done multiple runs where it came in the next day even. So the Airflow DAG will just keep retrying till this specific condition is true, and then it can go downstream.
Okay, cool. All right, cool.
Another thing to quickly check out is by folks at GitLab. They're working on Meltano, which kind of conceptually builds this DAG just from CLI without writing much.
Okay, cool. Thanks a lot.
No worries.
Cool. Jeff, are you able to?
Hey, yeah, thanks for the great presentation. We have a similar stack on here. You mentioned and foreshadowed maybe you wanted to talk about docs during your presentation. So I've definitely had a few issues with docs not being like rendering or compiling all of the model code because we have a similar split between daily and hourly. So I was wondering what strategies you have for consistently having that be complete and accurate for downstream business users, and also taking into account the occasional failed run. Thanks.
Right. So correct me if I'm wrong. Do docs depend on the data or the run in any way? Dynamically, do they change? Like, I'm not sure. I'm actually looking for people's response here because we didn't find anything changes.
I think I found that after one successful run, if I introduced new models, then the docs would update essentially once it compiles the new the added model. But maybe Claire can chime in here.
So what we are doing is we are compiling in CI and generating the docs, and then that's it. Because that is the source of truth for all the new stuff that is being added. In terms of code, right? Like the runs are mainly to update the data, and CI is, in my mind, supposed to do anything that is directly related with just changing the code.
Cool. What are you using for CI?
We use GitLab, so GitLab CI, but I think it should work for anything. It was funny that when we found DBT, we were like so impressed. We were like, come on, business people, you got to use DBT docs. But then it went down and it hurt us in terms of trust, because we were saying, go to DBT docs, but then my run failed, which happened for other reasons. And then DBT docs were not there and the data was there. So I was like, oh no. So then we just kind of, because it's super easy to set it up yourself as well. So we moved it to in-house. It's just a static site. So just put it on S3 or whatever. Or Git pages, whatever, easy.
Thanks, very helpful.
Josh Andrews here, Nehil. Thank you very much for a great presentation. My question was, have you looked at Prefect or similar next-gen orchestration solutions? I've listened to podcasts, doing some reading and so on, and hearing a lot of folks saying, look, Airflow was revolutionary for its time, kind of first-generation code-driven orchestration solution, but now, like so many things, there are a lot of kind of inherent issues with the assumptions made in building it and challenges. And one solution I've seen, I haven't used it, I have no skin in the game, but one solution I've seen coming along that says it can help with a lot of those things is Prefect or other similar things. So just curious, you know, if you looked at those and if you were starting from scratch, but you knew what you knew about Airflow, which I realize is sort of contradictory, would you still choose to use Airflow now, or would you say, hey, wait, I can see some of these things if I'm starting from scratch, that other tools that I don't want to have to deal with some of the issues around Airflow?
Yeah, I think that's a very good question. I was just trying to do justice to the title of the talk. Prefect is definitely very interesting. My depth of Prefect is very similar to yours. I've heard it in podcasts. I've watched a few like PyCon videos on it and how you would get Hello World going and stuff. It looks very interesting for sure. There's a lot of interesting stuff happening in Airflow, which will come out in Airflow 2.0 as well. Because it's under the Apache umbrella, they're kind of integrating Adminson and other things, which Prefect might not have. So starting from scratch, of course, if not starting from scratch, and if you have Airflow, then it's super easy to just tag on to the current infrastructure. But starting from scratch, I will consider Prefect for sure. But Airflow might get to a point where with Astronomer, it's like super easy as well. It doesn't matter.
So,
and as I said, like I'm also looking at Meltano. So Meltano is a way to just abstract all of this away. So let Meltano give me a connection to Airflow or Prefect or whatever for orchestration, and I just worry about my like tags.
Right.
Yeah.
Meltano is interesting. It seems like in the last month or two, the Meltano folks kind of took a step back and said, hey, like, we still want to do some of these things, but we need to rethink our approach and what we're aiming for in the short term. So let me ask this, just looking at the blog post about Prefect and comparing to Airflow, one of the things that they said that was challenging with Airflow is a DAG where you might need to exchange data between nodes or pass data down, or parameterizing DAGs or dynamic DAGs or other things. Have you run in any of those issues with Airflow?
Yeah, good question. So passing data around has definitely been a problem in Airflow. Again, in 2.0, they're completely changing how they pass data around. Mm-hmm. What we do is we just actually don't just pass the data between DAGs, because sometimes those intermediate results are important, so we store them outside of Airflow itself, and then and a task outputs it, and then another task reads it, and this task just points the location, which is easy. You just can't pass a lot of data, but it has been fairly easy since the beginning to pass small amounts of data between tasks in Airflow.
Okay.
Yeah.
And then go ahead.
Yeah. Parameterization and dynamically generating DAGs. So I haven't had a specific need to dynamically generate DAGs, but parameterization is fairly easy given the Airflow constructs, and we use that quite a lot.
Okay. Yeah. And then one final question, I'm done, I promise. So how much, I think one of the other big challenges about this stuff is like the staffing and the maintenance, right? As you add the complexity and you add the additional tools and you say, oh, now I have to start dealing with Kubernetes, or even if I don't have to manage it, I have to understand what goes on under the hood with it. And I have to have people who know Bash a bit more, and I have to do these other things. So what would you say, and I realize this would just be an approximation, but in terms of maintenance or staffing load or additional knowledge, in terms of FTEs or people that you need, what would you say is the incremental lift that you need to manage Airflow and kind of the underlying orchestration and infrastructure for it, versus if you just used DBT Cloud? Knowing that you have more functionality, you have to see, like, I know you need Airflow for additional things that you can't do in DBT Cloud, but I'm just trying to understand, like, if you wanted to add that, if someone else wanted to add that to their project, they would have to think, oh, but am I going to need another person? And what's the cost and the time and all that kind of stuff for that?
Yeah, for sure. I think, and that is a very good question to ask. And that's why I started by saying, like, if you don't have Airflow at all, really please consider DBT Cloud and look at it seriously. Don't disregard it just because, you want to be open source or whatever. But if I would have to answer that, and let's assume that the scope is only to run DBT on Airflow and not other use cases, because it will enable you to do that as well. I would say it's like 1 week of setup and properly productionizing it. And after that, I would give it 1 day per 2 weeks type of thing. So yeah, it's fairly minimal just for this setup. Because as I said, and in the examples I was giving, not a lot is changing. The stuff that's changing is in the DBT repo and your DBT package in a way. So yeah, but you have to set it up that way.
Got it. Okay, thank you.
Cool. We have one last question, but I'm very conscious of time. So we're going to quickly launch just a very quick feedback poll for this office hours. And then I'll throw to Chris, who has our last question of the session.
Yeah, thanks. I'm just curious, how much stress testing have you done on your deployment, and have you seen it scale in the case of like 100 models or more, or refresh frequencies closer to like 5 minutes?
Yeah, that is a good question. So some of the cases, like we need data to be more real-time from business. So we have definitely looked at making things run faster. We weren't able to achieve it. That's nothing to do with, again, Airflow, it's just overall orchestration. I think we weren't able to achieve it because the run does take about 30 minutes for our 300-ish models. So we were not able to bring it down more than that. What we ended up doing was we converted things to views where the data was real time. And I was really interested in Jeremy's materialized office hours, where he talked about Lambda setup, which is very interesting. Like in theory, you can now kind of hit both the use cases, the real time ones and accurate data batch ones. But we haven't been able to do that yet. The time does increase when you add more complexity, like incremental and stuff. And 17.0 really reduced the time it takes to, at least on Snowflake, to run DBT runs. So that brought it down, but overall it still takes a few, it takes some time. And then depending on how people are writing tests, it is possible that someone is trying to run a unique test on a really large data set, which will take a very long time. And then even if your run finished, your test might take longer than your runs, which is another thing, which is diminishing returns at this point. So yeah, we haven't been able to successfully achieve that.
Cool. Thank you again so much for this presentation today. So much, yes, such a depth of knowledge on Airflow. So really, I think it's a topic that a lot of people have wanted someone to speak on. So I'm really glad we were able to have you join us today. As always, to everyone on the call, we're really interested in any ideas that you have for office hours, whether that's something that you've worked on that you want to share your knowledge about, or something that you're really interested in learning about, and then we can try and match up a speaker. So if you do have any suggestions for future office hours, just let us know in the office hours channel on DBT Slack. And with that, I think this will be like the official close of the meeting. I'll hang out for an extra few minutes in case anyone has any extra questions. But yeah, thank you so much for everyone for joining us today, and thank you to Nehil, and also your bigger team at SnapTravel as well for the work that went into presenting today.